Our next example 3 is the first example where we finally will see some reflections. In fact, I see a negative in the front and a negative inside the function as well, so we're probably going to have 2 reflections. But as always, we'll start with our base function, so we'll write down a base function, y equals log base 2 of x. And again, I like to write it in the exponential form inside the box to help me do the evaluating. So when I raise something to the 0, because I find that to be the easiest one to start with, I get 1, 2 to the first by moving down the table will give me a value of 2, and 2 to the negative 1, again, just as a reminder, 2 to the negative first is 1 over 2, leaving me with a half. So I'll graph those 3 points. Now they're awfully close together in this case, so you're going to have to be really careful when you make that sketch that you are not crossing where the asymptote would be and trying to make it dashed. So as I go to identify my shifts, I notice a negative in the front that I'll kind of point to with a blue arrow. And the one that's outside the function means it goes over the x-axis. It says in order to be outside it affects the y. When it affects the y it goes over the x. Then I'm going to choose a different color of purple, and I'm going to notice this guy, and he's going to be the one that is over the y-axis. Now you can do those at similar times. I'm going to choose to do them distinctly right now to make sure that we are processing. The order of these 2 reflections in terms of graphing them does not matter. I will do over the x-axis first. So I'm going to take this point that's above the x-axis and bring it below, and the point that was below and bring it above. Now that I have multiple graphs, and yet neither one is my final graph, I really should number them. So I'm going to say that this green graph was my first graph, and I'm going to say that this blue dashed graph is my second. I'm also going to do the other reflection, so I'm going to take this blue point where I just most recently was. It's 2 to the right, and then I'm going to bring it over the y-axis to 2 to the left. This is 1 to the right, so I'm going to bring it 1 to the left. This is a little bit right, technically a half right, so I'm going to be a little bit left. And those points I'm going to create into a curve. Now you'll notice that I went ahead and made that solid. And the reason I was able to do that is because I could anticipate, since I saw no other numbers, that there was no horizontal shift and no vertical shift. So if there is no horizontal shift, we know that from our previous examples that the horizontal shift and the asymptote are connected. So if there is no shift, I would expect that asymptote to still be where it was way back here in our opener, right, our general parent function at x equals 0, and it is. Similarly, I would expect my domain to involve that 0 value because it's an x and this is an x kind of asymptote and an x kind of movement, so we're all linked. The difference is, if I were to look at my graph and pay attention to my asymptote, I believe that those purple points on my final graph are to the left. So I want to start at negative infinity and stop before I get to 0. So these are both parentheses. My range continues to be all reals, so I don't have to spend as much thought process involved in coming up with that final response.